Hi everybody, welcome back. So you can tell by the opening scene here what we're going to start out with. I was able to kind of get this out far enough to get into it, and as you can hopefully you can see, I did manage to get this re-glued, but it's still, the wafer's just so messed up at the bottom that it's not really possible to get this positioned in a good enough manner. These are so delicate, and I just don't do enough work with these wafers. And I know that I'll tell you what, the comments were coming out of the woodwork for suggestions for this, and they were awesome ideas. And I did see somebody sent me a link to Surplus Sales of Nebraska, and I do deal with them. And they do look like some of those wafers may be possibly would work for here. I don't know, but my big concern is if you look at these, the way this thing is wired, this would be just an immense undertaking trying to get this apart. I've already gotten myself in a little bit of trouble. And if I can find what I did with my pointer here, here it is. If you look down here, this capacitor has been disconnected, and there's another one right here that's been disconnected. And here's one of the wires. The other one is way underneath. I have no clue how I'm going to get to that. It's going to just take some time and patience, but I will try to get those reconnected. I had to get those off, number one, to be able to replace them, but number two, to be able to get this up far enough. And I'm afraid to go any further because I do not want to stress these and break any of these tabs off of here on these other wafer. These other wafer switches are still good. It's just this one section here. And I might be able to jumper these two together because all it does is it looks like it just kills the power to the tuner when you're not listening to the tuner. I'm not sure why they do that, and I don't know the ramifications of if we leave it powered up all the time. I don't think it's going to cause a problem, but I'm going to look into that a little more, and possibly that's the solution we're going to use on this. I don't want to get too much more fancy than that. The other problem is, and this isn't really a rant, but this is just some of the challenges here that I'm going to have to look at. If you notice, everything, and I mean everything, is riveted. So even to try to remove these other switches or these pots are connected to, I don't know if you can get in there and see, but these terminal strips, and they're all riveted in, and without removing and unsoldering all this, you can't really even get these out to work on them. So this is a very challenging, I think when they assembled these, you assembled this whole thing as one big chunk, and then you attached it to the chassis, and then you wired it to the rest of the amplifiers, how they did it. This is not a kit, by the way. This is a factory built. Somebody had mentioned that, but if you look, for instance, you see all these little red marks here, like right there. You see that solder joint is red. You see the red paint there. And here's red paint. Red paint. See, anywhere, those are inspection marks they put on there. So, again, this is a factory-built receiver. And it's just very complicated and wiry. So we're just going to have to take our time. So, as you can see, it's glued up. It's tight. And I'm going to try, I don't know how I'm going to get down. I'm going to try to go from the other side, although it's even worse there because I will show you. When you pick this up and I bang the camera, you can see this L bracket with these tube sockets is covering right where we need to be, and it is riveted on, and it's all wired in, and so you can't get in from that end, and I can't move this forward any further than it is because there's just too many things wired in there. So it's just going to take some time, and hopefully we'll be able to do something here. But that's where I am. So as soon as I get that switch, something done with it, I'll come back. Well, it would help if I put my microphone on. I'm not a video person. So you can see I have the switch all back in after gluing it, and you can see it does make continuity now. If I turn it on and off, it works. But I can see that those contacts are just barely touching the rotor, so I'm still not convinced that that's going to be good enough, but maybe it will be. The only other thing is I may just put a jumper between those two leads and call it a day. I can't see anything in the schematics that would harm it if I did that. And we can always remove the jumper if it doesn't work, but I think I'm going to do that. While I was in there, I was able to clean up and remove all of the capacitors that were on the back of the chassis. I was able to kind of swing this out just a little bit from the other side, kind of swing it this way, and lo and behold, inside there, crammed in, was all of these. So I replaced them while I was in there, and it was no easy task. Again, this thing was filled with embalming fluid. I mean, you could see my fingernails, you know, just from touching these, how oily. Guys, that is not restoration fluid. This stuff is to be used very sparingly. And if you just hose everything down in there, everything gets this coat of greasy, nasty grossness. And it makes it really hard to service these things. You can see just everything here is just oily from that. Somebody really sprayed this thing like a cat in heat, I'm telling you. But I cleaned most of that off, and I think we're going to be in good shape now. So we're going to put it back together and see if we have a power supply now that works. Okay, so the first thing I did was see that yellow wire down there. I ran a new wire through that lead because the old one was just so crusty, and it literally would just, it was so brittle it would just break as soon as you tried to twist it around. You can see where it comes out right there, it goes in. I did jumper the two leads together, if you can see it down there. And I'm connected to, and I put a new blue wire in because this blue wire again was brittle and gross. So for the moment of truth, let's turn this thing on, plug it in, and here we go. Of course, the tube has to heat up. Look at that. We've got voltage. And there's some kind of capacitance on there, as we can see in there, so I don't know. With this being disconnected like that, I'm not really sure how the capacitors are working, but somehow there's even a capacitor in there. So we'll have to look at how the switch is wired a little more closely, but at least we know that it works. Now we're going to have to rebuild the can dome resistor. Okay, so I'm in the process of replacing this can dome resistor and this capacitor here. And I just drilled out the rivets. Like I said, everything in here is riveted. So we're going to replace these with some low profile screws. And I'm just trying to get my mind wrapped around if our resistors will work or not. So we do have some good information we can use to see. Because if you recall, I have these little 3-watt resistors. And these two are just normal metal film, 250 ohm, 3-watt. This one, however, is also, I believe, metal film, but it's very high precision. It's all I had left. I didn't have 3 of these. It's also 3 watts at 250 ohms, but it's just a very high, like 0.1% accurate. You really don't need that, but it's all I had, so I'm not going to place a special order for right now. So I'm just going to use these. Now, the question is, will the 3 watts be enough? Well, we have some good information here that we can use. First thing, if we look, they're saying 190 volts is what's coming out of the 6X4. They're saying that under normal conditions, there should be about 70 milliamps here. And if we follow this through, it goes through this entire network, and when it comes out and goes through all of this, it's a 145 volt source. So even if we didn't know about this 70 milliamps, we could go to the calculator, and if we take 190 volts minus the 145 volts at the output, we find out that this resistor network will have a 45 volt drop. So knowing that we have 45 volts across this network, if we add these resistors up, because they're in series, that would be 750 ohms, right? 250 times 3. So I equals V over R. So if we take 45 volts divided by the 750 ohms, it gives us 60 milliamps, or 0.06 amps, which is very close to what they're saying up here. So let's go with their number, 70 milliamps, just because. And if we take the 70 milliamps, 0.07, times the 45 volt drop that's imposed across them, you can see the total wattage for the entire network is 3.15 watts. Now each one of these resistors can dissipate up to 3 watts. So in total, we could have 6 watts dissipated, or I'm sorry, 9 watts dissipated between the 3. So we have a factor of 3 margin for this. So I believe these resistors should be okay. They'll run a little bit warm, but they'll be okay. It would probably be better if you put 5 watt resistors, and if I had them, I would use those, just because they'll run cooler. They won't get as hot. But this should be just fine, and they won't burn up, and they'll work, at least temporarily, and we can always replace them. But you kind of need to check that sort of thing out when you are doing this, because you really need to make sure that the resistor can dissipate the amount of heat. Because remember, as I've said before, the way a resistor works is it converts electrical energy into heat energy. That's how it dissipates however much power it has to drop. So anyway, that's it. And if you look, this is called a pi network, because if you look at this, it kind of looks like the pi symbol, pi. And you can see it's done in 3 stages. So you can see the whole purpose of this is a very high amount of filtration. So they really want this power supply to be very, very quiet. If you notice, there's no taps coming off of any of these. So really the whole purpose of having these 3 is just to have a very, very low noise power supply. So today we would use a semiconductor voltage regulator and get the same results, but this is the way we did it before, in the old days, before they had those sorts of things. And this actually it'll be surprising how quiet you can make that power supply by doing this. So let's wire it up and see what it looks like. Okay, so as you can see, I have the resistors mounted up in there, and I haven't soldered any of them yet. For the capacitor, this is a 4-section capacitor. So it has, if we look at it, it has 4 40 microfarad at 250 volt capacitors inside there. And it's a Sprague. This is a very good capacitor, but as you could tell, some of it was getting kind of old. I mean, this thing's almost 60 years old. I mean, it's 50 some years old. So I would have to say that this should be replaced. So we're going to do something different. There is a company called CE Manufacturing, and they bought out I forget the name of the company they bought out. It was Sprague or Cornell Dubilier, somebody's can capacitor factory, and they're making new can capacitors. The problem is those get very expensive. Just to give you an example, something like this would cost anywhere from $30 to $40 US. And this thing has 1, 2, 3, 4, 5, 6, 7 of them. So you can imagine how quickly the cost can go way up on these. But I don't want to mess around with terminal strips if I don't have to. I would rather keep the same footprint. So I'm going to try something new that somebody suggested, one of the viewers suggested. I'm going to use this. And you might ask, what is this? This is a little thing called an adaptacap. You know, it's the silliest idea. I don't know why we haven't thought of it, but this little company came up with this little patterned board, and this fits right into place of a can capacitor. So if you look, here's the mounting ring for a can capacitor, and it fits right in the same footprint. And you can put whatever type capacitor on here within reason. You could see they are size limited, but you can put any capacitor you want and make up whatever configuration. The other thing I noticed is these, here's all your grounds. So here's the common negative of the capacitor, but they're isolated from this outside ring unless you bridge these two together. So you see this particular is your outside ring, this particular solder pad, and it goes to these. So if you want the actual tabs to be connected to the common negative, you just jumper these pins together. If you want them to be an isolated capacitor, then you don't jumper these, and this just is a common negative right here, and it's isolated from the tabs. So it's pretty versatile. And again, sure, we could make these ourselves and send them out and have them printed, but I thought, you know, I never thought of doing this, at least like this. So we decided to order some of these from the company and try them out. Because I think when somebody comes up with a good idea, I think they should be rewarded. And here you go. This is what they sent along with it. It was really cool. This was a freebie they sent. You can break this out and use it as well. But if you want to take a picture of this, it has the name right there. I'll try to hold it still, and you can freeze the image and read it if you want. But we'll see how they work out. So what I did was I used 4 47 microfarad at 250 volt caps, 105 degree, so they're good caps. I attached them like this with the leads, and this one has a bleeder resistor on it, if you look right there. So I did the same thing with this. I put it on the bottom, and then I used a couple of standoffs, and I'm going to mount it right like this, and you can see it'll fit perfectly right into the existing mounting holes. And then I used the same colors of wires to reproduce what they did here. So I'm going to remove that old capacitor and so forth, and I'm going to install this new one, and we'll see what it looks like when we're done. And there's the finished product. I kind of like these little things. I think for certain applications they'll work out. Now, of course, with larger capacitors that are larger diameter, there's no way that you would get those on here unless it was going to be a 1 or a 2 capacitor unit. But if to fit 4 high voltage caps, like into the 450 volt range or whatever, you're probably not going to find slim enough capacitors. They do make, I know Nichicon makes some, and so do Panasonic, but it's hard to find those really narrow, long ones that'll fit on here. So you're limited by the size of the capacitors. But all in all, I really like this little invention, and the other nice thing about it that I may try down the road is it looks like you can probably cut the can off of these and use the can to cover up the capacitors inside to give it that look. But we'd have to experiment with that to see how that works out. But all in all, I think this does have some use. So here's our resistors. It's all rewired in with new wires. I rerouted this ground, and we'll see what happens, but I put it down here on this ground lug, and then I came across with here and tied it over to here, although I don't think that would be necessary. But just in case, we don't want to mess with any ground loops, but we know what we've got, so we can adjust that if need be. But it looks a lot neater, I think, and you're not stretching this wire into a banjo string, which I don't want. I don't like banjo strings in my amplifiers. Anyway, time for another power up. Okay, we're connected to the first section of the resistor here. We have our voltmeter hooked up, and we'll just go down. I don't know if this is the input or if that's the input, but we'll find out. And I'm going to move you over to the dim bulb first, because I have not turned this on yet. Well, actually, I'll keep you over here, because the action will be over here. If something goes wrong, you'll see it here, because I know some of you like to see sparks and smoke. Hopefully we won't have that, though, and we'll see what the dim bulb does. I don't think the dim bulb will do much of anything, because you have to wait for the filament of the 6X4 to heat up before the voltage comes up, so it brings the voltage up slowly, so we really should not have much of a surge current. All right, let's see what we got. That's not good. So something is wired wrong. Turn it on. Yeah. Okay, let's see what Tony did wrong. Okay, as it turns out, it had nothing to really do with my mod here. Well, kind of, but not really. But what happened was our short on the filament circuit came back. In other words, when I soldered this wire here, this ground wire, to the ground lead over here on this little socket down here, that short on the filament circuit came back. If you go back to the previous video and you saw where I found that, I'm beginning to think that something in this socket, there is an intermittent short. I don't know if it's on the top of the socket or what it is, but by heating this up over here to put this wire in there, that short came back. Now when I removed the negative side of the filament winding and this ground lead for the 145 volt supply, of course I have to tie them together, and it's getting its ground from this wire here now, and it's not touching this lead. You can see, I turn it on. No, the bulb doesn't light up at all, so there's hardly any current, and you can see that now our power supply is coming back to where it belongs. Now, of course, it's high right now. It's 245 volts, and the reason it's 245 volts is because there's no load. I don't have any of the tubes in the circuit, so there's absolutely no load on it, so that's why it's sitting like that. So I'm going to turn that down, because that's right on the edge of what those capacitors are rated at. Those are only 250 volt caps, and normally, under normal circumstances, that would only come up for a second like that, and then it would drop back down as the voltage, as the tubes start to draw current. But anyway, very interesting. So I may end up having to put a new socket in there, unless I find somewhere where there's a short of some sort. So let me take a look at that. Okay, problem solved. If we look, this is really hard to zoom in close enough, but right here is our socket, and coming off of the other side of the filament, you have this coil, and it goes to this other tube here. And if you notice, right here is the lead going over. So that's your one filament lead. And if you look down here just a little bit, there's a ground wire that's a bare ground wire that's going across the back of that terminal. And you can see that terminal is just bent down just a little bit. Now watch when I turn this on and wiggle that wire, what's going to happen to the dim bulb. So here we go. Let's turn the bulb on. It's off right now, right? All I got to do is touch that wire just a little bit. And see, it's no, well, see, I have it bent away now. See it? That's where it was. So, bottom line, I have to move that terminal. That's the problem with all of these uninsulated leads in this thing. If you move the lead dressing even the tiniest little bit on this receiver, you will cause shorts. And you can see nothing has spaghetti tubing on it, hardly at all. And there's some big long leads going around in there, and if you just bend it the tiniest little bit, you're going to end up with problems. So I'm sure I bent this down when I removed that wire, and I'm sure I caused that problem. And actually this capacitor is also connected to that lead, and it was kind of twisted. And you can see the capacitor goes to ground on one side and goes to that pin on the other side. And this thing is just a royal mess, the way everything's so tightly packed in there and uninsulated. So let's get that straightened out, and that will fix that problem, no doubt. I don't really know if I can get there close enough or not, but right there is where that filament lead comes in. See this black wire here? There's the capacitor, and it goes between this pin and this pin. And this pin is tied to ground, and then behind this cap here, you'll see this pin right here has a bare lead going across, and it goes to this blob of solder to ground as well. And when they put this disc capacitor on this lead, they terminated it right at the bottom of the terminal. So where the lead bends out of the capacitor, it is literally a millimeter from touching that ground wire. So if you bend this the tiniest little bit, it'll short that out. So I don't know, I may clean that up if I can. I don't want to break the capacitor off, but of course I probably have another one I could put in there if need be. But that's what we're facing on this thing, with all these leads in here, and no shield, no tubing or anything on any of the leads. Okay, everything's connected back up. Let's turn it on and see what our voltage does. There it goes. Now I don't expect this voltage to drop because there's no load on it, so there's 250 on that side. On the other end, it's the same. You see that? And the reason the voltage hasn't dropped at all is, once again, because there's no load on the circuit. I don't have any of the tubes fitted into the sockets. So the good news is the power supply is working. Everything is good. And I think we're finally ready to move on to the other power supply, the big power supply. So we're going to check that next. Okay, I've now removed the 6X4. We're done with this. We know it works. I don't want to put power on these caps on an unloaded supply. So we're just going to leave that off for now. And then I'm going to look over here, and I just put in the GZ34, and we should see our 380 volts, and this is going to be way high also. And I just want to see if we get 380 here, and then we'll chase it through and see if all of these voltages are there. Now, of course, they're all going to be way high, because once again, with no load on these, they're going to float up to whatever this is. So if this is 340 volts AC going in here, and 380 coming out, this is actually going to be higher. It's going to be 340 volts times 1.414 minus the voltage drop across this, which these have probably about a 10 or 15 volt drop. So you could do the math 340 times 1.414 equals, so you're going to have about 480 volts on there, minus that, say, let's just say it's a 15 volt drop, minus 15. So you're going to see about 465 volts here if there's no load. That's what it'll float up to. And that's why the capacitors that are in here, if you notice, they don't say it, but these caps are all rated at 500 or 525 volts. And that's why you're going to see somewhere around 465. So that's what I'm expecting to see when we turn this on. Now, I could be wrong. And of course, the dim bulb may take up a little bit of that, but it should be close. So let's move this over to volts again. And I have it connected into the circuit. Let me plug it in. And let's see if we get our 465 in there. And you can see the dim bulb flashed a wee little bit there now because that GZ34 draws a lot of current. Now the bulb is very dim. And our voltage is climbing. It should go up pretty fast. Hopefully we won't pop a capacitor. And you can see how it's staying at 260 volts and the bulb is getting brighter. That tells me that one of those capacitors is shorted. So the bottom line is, once again, we cannot safely apply power to this without recapping the power supply. Now, that being said, you can do the brute force thing. We could turn this on through a dim bulb and power the whole unit up and let it sit there, and hopefully the capacitors would warm up and reform. I'm not a fan of that. There's just too many variables that I don't like to do. So we're going to recap. And if you recall from the first video, we determined that a couple of these capacitors were really, really bad. All right, I got this first capacitor in. You can see I'm using an adapter cap again. And that represents this capacitor here and this capacitor here. Right there. And one of the things I noticed is they do have, even though this whole thing is chassis grounded and it's not isolated, they do have all the caps mounted up on these little isolated fiber wafers like this. And it's kind of strange, but all of the negative terminals of these caps are all tied together, and then they go in one point onto the chassis. So they did have a rudimentary form of star ground on this, I guess. And I'm going to try to keep it that way. But one of the things is all of the grounds, if you look at this wire, look how bad that is. I mean, it just, and all the ground wires came out like that. You can see, and the copper is just corroded inside. Now this is not because the plastic deteriorated or broke down, because there's lots and lots of these black wires in here that are not like that. Only the ones that are tying all the negatives together of the high voltage capacitors did this. So they got overheated is what that is. And again, that's just showing that some of these caps are probably really bad. The other thing I did was I cleaned up, if I can get over here, I cleaned up this power cord mess and put a new cord on it, and it looks a lot better now. A couple new safety XY safety capacitors. So we're ready for another test. And in case you want to know what this looks like underneath, I don't know if I can get the camera down there. Yeah, we can. So you can see the capacitors in there. Those are the two new ones. And they're rated at 500 volts, you can see. Okay. All right, now our next little challenge is this section right in here. Actually, this section here, this capacitor. Where is that, you might say? Well, we just did this, and this was the one that we replaced. And now we're looking at this branch going down here, and there's a 22K resistor which is R169. And if you look, that would be this resistor here at the bottom. So you can see where it connects here with this wire. And if you look, it is not 22K. In fact, if it focuses, it's a 2.2K. Now that might be a typographical error, but this is off of a schematic that, where is it? Right here. This is off of a different schematic than the Sam's photo fax that I have. So let's open that one and look at it and see if it disagrees. So we're going to go over here. All right, so there it is. And again, on the Sam's photo fax, they're showing it 22K. So maybe it's a typographical error in the schematic. So we go through and we look at R169, and sure enough, 22K, 1 watt. So what gives? Looking at the terminals here, you can pretty plainly see that this is factory. This has not been soldered on that I could tell at all. And to make matters even a little more confusing, take a look down here. Here's this blue wire here, and there's another blue wire here. They both go to this lead on this capacitor. This is a 2-section capacitor can. But if you look here, this wire was just kind of bodged in there, and you can see the bubblegum soldering job on both of those. But look here. Can you see that right next to it? I'll try to point at it. Right there. See that blue? There was a blue wire on there at one point in time that had been cut off, and then somebody wound this around. So somebody has been in here messing with this, and something is not right. So we now need to figure out what's going on with this section of the power supply. Now the rest of this, for instance, let me back up. So we have this 47K that goes to ground, and a 56K feeding it off of all of this. And that all is right here. So here's your 47K half watt. It goes to this terminal, and then there's this white wire here, and it goes to the ground terminal on this cap. And this resistor down here, this 1 watt, you could kind of see it in between all these. That's the 56K. And it's coming off of here, which is coming off of here. So you can see that part all makes sense. The only part that doesn't is this 2.2K. Obviously it's been like that. So the question remains, is this a modification that was done at some point in time? Or did they just put the wrong part in here at the factory when they built this? I don't know. I mean, it worked for 60 years like this, so I'm inclined to leave it alone. But definitely something's been done here, and it looks like this blue wire should have been here, not over here, but I don't know. So I'm going to go through all this and try to figure it out. And once I do, I'll come back and I'm going to replace this capacitor and get that all fixed. Okay. Remember how one of the wires had been cut and moved to another terminal on the capacitor? Well, essentially what it was, let's open the schematic here. If you look over on, let's see here where we are, I believe in the preamp section. Where was it? Or no, it was up here in the AF amplifier. You could see this 230 volt going through this 100K and then going to the plate of this 12AX7 for the AF amp. Now, there's 2 wires. There's one that goes over to this side, and it connected clear over, like way off the camera here up at the top. And the other one connects to the same thing over on this side. And it essentially goes to these 100K plate resistors. They need to be tied together on here. And what they did was they had relocated one from here over to here. And what does that do by doing that? Well, what you did was you had one channel. What they had was one channel was being powered from the correct 230 volt source. The other one was being powered through this 175 volt source. So yes, the amplifier probably worked, but it definitely didn't work properly. So this amp has been worked on. It had a lot of work done on it, and a lot of the wiring. For instance, there were 2 or 3 little thin wires going to connect the ground terminals together between the capacitors. Instead of one wire, they'd have 2 or 3 going to the same point. And it looks like they had just removed them and just put more in or something. I'm not really sure. And a lot of the wires were very brittle, so you can see a lot of these had to be replaced. Other ones were in good shape, so I left them in. But as you can see, we did quite a lot of work. This capacitor I was able to eliminate and put these 450 volt 22 microfarads. There was 2 of them in here. And then the other 2 were 25 microfarad at 25 volt. And they were the cathode resistor and cathode capacitor for the 2 channels here and here. So what I did was I relocated that over to this terminal strip. I put a terminal strip in right here, and you can see I had to replace a couple of these black molded capacitors to get them out of the way and put the newer ones in. And you can see with this here, now everything's star grounded to here, and we have our resistor and capacitor, and I just put a Sprague atom in each one of those. I had 2 of them left, so I put them in and connected it to the tube. So this is going to be much better. Rather than having wires running back and forth everywhere, everything's being taken care of right by the tube. So now I just have to replace these couple of caps here. I have 3 of them left, but slowly but surely this amplifier, the power supply, is getting rebuilt. And the more I get into it, the more I'm seeing a lot of very damaged wires. So for instance, this was a ground wire, and it went all the way from the deck switch over here, and they just had it strung this way, and then it went to the ground lead right here on that capacitor, like that. And you can see it had all kind of burn marks on it, and kinks in the wire, and it's very brittle. If you bend it too many times, it just breaks. So as it turns out, and I'll just give you an example, quite a few of these had to be replaced. I mean, this is just some that I could grab in my hands. But these were all bad ones. You could see some of them had been taped. So little by little it's shaping up. Okay, all the can capacitors, as you can see, have been replaced. And I cleaned up a lot of wiring. And we'll get into that in a minute. But these 2 capacitors here were kind of interesting. If you look at them, let's see if I can find one of them. Here we go. So here's one right here. And if you look, common positive, you see that? And there's 2 of them that were like that. Where's the other one? Right here. Again, common positive. And every one of these caps is original. You can see they were made 1959, 39th week for this one. They're all 1959 vintage. But these ones actually, the capacitors are backwards in there. They're common positive. So the can is connected to the positive, and that's because of this negative power supply. So if you look at all these down here, notice the positive is going to the ground on all of them, there and there, here, 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 and so forth. So no problem. That would be a big problem if you tried to order these, because you can't really get common positive CAN capacitors anymore. So I'm really glad I got these little, what are they called, the adaptacaps, that worked out really well. All I had to do was just put the capacitors in backwards and they were all common positive. So that worked out really well. It looks really neat. I like the way it wired up. So let's get into a few things that I'm finding. The more that I work on this amplifier, the more I realize this had some severe work done to it. And I think the main thing was whoever it was that tried to repair this at some point in time over here tried to remove this whole front, and it looks like they removed a whole bunch of wires, and when they put them back in, they did not route them like the factory originally had them. That's why there were wires just scattered all over the place. I mean, there was wires wrapped around this resistor going back and forth, and just, it was a terrible mess, and it took hours and hours to straighten just to the point it is right now. It's still not done, but at least things are kind of in a little better order. The other thing I noticed was one of you on the last video had commented that you noticed a capacitor that didn't look stock. All the other ones did. And that was this 1 microfarad. And sure enough, this is not stock. It doesn't belong here. For some reason, it was attached to this little, this is an RCA jack right here. You see it? And it's actually the multiplex output jack. And for some reason, somebody put an electrolytic capacitor on the multiplex output jack. And I can't for the life of me figure out why you would ever need to do that or want to do that. If we go, let's see where it went. Right here. Let's see if I can get it on the camera. Let me move the camera up a little bit. If you look right there's your multiplex out. And if you notice, there's just a 4700 picofarad capacitor, and that goes to your output for your multiplex. For some reason, they didn't even bother removing it, this one. They just shunted this capacitor across there like that. I don't even know why. I mean, it doesn't make any sense. It's RF coming out of there. Well, it's not RF, but it's a multiplex signal coming out of there, and I really don't know if they were trying to get a higher signal strength or I don't know. But there's a lot of goofy things in here. Strangely enough, none of the components other than that had been replaced. I mean, everything in here was original. It's just the wiring had been all messed up and moved around, and I think that was all part of trying to repair this front. So all of the power supplies are rebuilt now, and that other CAN capacitor, I just used a terminal strip to take care of that. I did make one change to the design. This capacitor belongs here on the output of the bias adjust. That's this cap. It was actually in this CAN over here. No, it was that one that jumpered across here. It was kind of a strange thing. Or no, it was one of the ones in here. I actually relocated it over here because it makes more sense. There's the pot. So the capacitor is right next to it. So I'm ready to flip this over and see, and put some tubes in it and see if it powers up. Okay, now that we have the power supplies done, let's do a quick test. I've fitted all the tubes in here. And the way this thing's laid out is all of the radio tubes, all of the outputs are all powered by the 6.3 volt AC line. These two tubes and these two tubes, which are your preamp and your phono stage, the 12AX7s, those are powered with that DC power supply off of the 6X4. So the first thing we want to do is turn this on. I've set the knobs according to the faceplate back there. I think it should work. Let's turn this on and see if we can get any sound. And I have this, I counted the amount of clicks for these two, and I think I have it set to the input selector for the auxiliary input. So we're driving just a 1 kilohertz tone into there. So let's see what we get. Okay, and I have 2 bulbs in because this thing draws a lot of idle current to heat up all these filaments. So you can see the 2 bulbs there, and they're very dim, which is a good sign. And looking at the meter, we're sitting at about 104 volts going into the receiver, and we're drawing about 700 milliamps, which I would say is a pretty good. And now the voltage is dropping a little bit because the rectifier just heated up. So now we're getting some conduction there. So let's look up at the scope and see if there's any kind of output at all. And by the way, I'm a little bit, I'm being a little bit of a chicken here. I did not put in the 7189s. Instead, I fitted a set of 6P14s EVs, which are a really good substitute for the 7189As. Just to make sure if anything goes wrong, I'd rather sacrifice tubes that you can still get rather than tubes that you cannot. Alright, so let's turn the volume up. Okay, looks like my balance control is off. And nope. Weak channel. Very weak channel. So we're getting output. I guess that's a good thing. Now these DC heated tubes here, these 12AX7s, I'm just checking them right now. They are absolutely ice cold. I know this wasn't on for very long, but all of these are just a tiny little bit warm because they came on already. The outputs feel good. They're warm. This side's hotter than this side, so the bias might be low over here. But all in all, for a first power up here with everything in there, I'll call that acceptable. Of course, we're just going to have to now go through and find out why it's not working right. But of course, we have all the original capacitors and resistors. Other than those few caps that I replaced, anytime I had to remove a capacitor to work on the power supply or the wiring, I did replace it with a new capacitor. So those are the only ones that got changed so far. I really haven't done much testing on any of that, but so far so good. Okay, so I think that's enough for this video. We got an initial power up, and at least we know the amplifier somewhat works. So let's get this one uploaded, and we'll just continue on with our work. But I think we're now seeing a little positive ground here. So, all right. So in the meantime, as always, I wish you all peace, joy, happiness, and good health in your lives. We'll be back really soon with the next part of this, and hopefully the amplifier will be working really well for the next one. We'll see. That's what I'm going to go after. And then the last thing I'm going to tackle is the tuner, because I think they messed with it and there's probably going to be issues with it, and that's going to be our challenge. But it all looks to be here, so we'll see. Anyway, stay well in the meantime, and we'll see you soon. Take care. Bye-bye.